This is a short presentation about how to read the Prisoner's Dilemma matrix. The Prisoner's Dilemma is a two-player game, which can be represented in a matrix. Frank and Jesse have just robbed a bank. They are held by the police for interrogation. Frank and Jesse's choices of behavior are to confess or not to the crime. We are representing Frank's choices in the columns yes and no in red, and Jesse's choices in the rows yes and no in blue. Now, each person's jail time depends on the choices made by both, to confess or not. For example, if neither says anything, they go to jail for 2 years. This is represented by the outcome -2 -2 in the lower right cell of our matrix, corresponding to the intersection of column no and row no, since they both do not confess. Jesse's outcome is the first number in blue, and Frank's outcome is the second number in red. The outcomes are always represented as that of the row individual first and the column individual second. Row, then column. Note that we have negative signs in front of the 2 years jail sentences to illustrate the fact that the longer the term in prison, the worse the outcome is. If both confess, they go to jail for 5 years. This outcome is represented in the upper left cell of our matrix at the intersection of the yes column, Frank confesses, and the yes row, Jesse confesses. Jesse's outcome is the first number in blue, and Frank's outcome is the second number in red. If Jesse confesses, yes row, and Frank does not, no column, the outcome is found at the intersection of the yes row and no column in the upper right corner of our matrix. No jail sentence for Jesse, first number in blue, 0, and 10 years in prison for Frank, second number in red. If instead Frank is the one who does confess, while Jesse does not, we have the opposite outcome. This outcome is found at the intersection of the no row, does not confess, for Jesse, and yes column, does confess, for Frank, in the lower left corner of our matrix. Jesse is the one who ends up going to prison for 10 years, and Frank comes out with no jail sentence. This was a short presentation about how to read the Prisoner's Dilemma matrix.